What we're going to take a look at now in our advanced algebra class comes from one of your homework problems. That's page 673, number 17. We're provided this three-variable, three-equation system in which we need to solve. Now the method that I showed, we're using the Gauss elimination, the elementary row operations, to simplify this. The four rules that we learned in class. Rather than having a matrix form, we're going to leave it as equations to simplify. Now one thing I want to point out, or two things I want to point out from the very beginning, but this one's a little tricky. One thing I want you to notice is that equation 1 is all divisible by 2. So if I needed to simplify this, I could divide everything by 2 and I would still end up with integer coefficients. Same thing with equation 2. Everything's divisible by 3, so I could simplify this equation quite a bit if I needed to. So that's definitely worth pointing out. The second thing is that it's kind of tricky in the fact that we have a lot of gaps. Every equation is missing one of the variables, but they're not the same, and that's where the issue lies. We're going to have to add two equations together to knock out a variable. What I'm going to choose to do here is, and again, there's always multiple approaches. What I'm going to do is I'm going to take and I'm going to multiply equation 2 by -2 in hopes that I can get rid of this y term, because I'm trying to get the same variable gone in equation 2 and equation 3. Again, I'm going to not change my equation 1, so I'm going to redraw my curly brackets. I'm not changing equation 1, so I'm going to rewrite it. 6y plus 4z is equal to -12. But in this case, I'm going to multiply, so I'm going to take row 1 and I'm going to add to it -2 times row 2. Okay? And when I do that, we're going to see that the y term cancels. I'm going to use the space below it for all of my arithmetic. So I really have 6y plus 4z is equal to -12. And again, this is my arithmetic, what I'm doing to try to fix them. So -2 times row 2, again, like I showed in class, I put my finger right next to it so that my eye goes to it. We've got -2 times 3x, which is negative, I'm one too far over here, -6x, and then -2 times 3y is -6y, and then that's equal to -2 times 9, which is -18. When I add these two equations together, we see that we get -6x, the y's cancel, plus 4z is equal to -30. Again, these are all even numbers, they are divisible. This is just my scratch work. Okay, so I'm going to take this equation, I'm going to write it up here. So I have -6x plus 4z, and that's equal to -30. And I'm not changing my third equation. So I'm going to write it as 2x minus 3z is equal to 10. This is scratch work, so I'm going to put 3 lines through it in order to not confuse it with anything else. Now, looking at this, we're exactly where we want it. We have this equation here in x and z, this one in x and z. Once we have the same variable missing in this one right here, we won't use this top one, because if we use the top one, it's going to reintroduce a y, and we're actually going to be going backwards. Okay? What I need to now do is to cancel out one more variable in this third equation. The thing that catches my eye is I've got a -6 and a +2. If I multiply equation 3 by +3, the x is going to cancel in the second one. So again, I'm going to rewrite equation 1 and equation 2 because I'm not actually changing those. I'm using them to manipulate. So I have my curly bracket, and we rewrite the first one. 6y plus 4z is equal to -12. I'm not changing this one. And my third one, what we decided to do was to take row 2, and we're going to add to it 3 times row 3, and it will give us this. Now I'm going to use my arithmetic again. So I'm looking at row 2, which is right below my index finger here. I'm going to rewrite it from my scratch work. -6x plus 4z is equal to -30. Now I multiply row 3 by 3. It gives me 6x. 3 times -3z is minus 9z, and 3 times 10, that's equal to 30. We're going to add these two together. You will notice that the x's cancel out. 4z minus or plus negative 9z is negative 5z is equal to 0. This is our new equation, our third equation. So negative 5z is equal to 0. Notice that we have something that is similar to a triangular form, except that that first equation actually only has two variables. Sliding my paper up, I now go and I use back substitution several times. This one can be easily calculated, so we know that z must be 0. That's a keeper. Now we use z to solve in the other two equations. So if I look at negative 6x, again I'm looking at equation 2, plus 4 times 0, I'm substituting in z, or 4z, is equal to negative 30. That means that negative 6x must be equal to negative 30, therefore x must equal 5. That's a keeper. Alright? Now, my top equation, same process. Equation 1, if I have 6y, slide this up a little ways, 6y, and that's next to this finger here, plus 4z, but we're substituting in, plus 4, z was 0, and that's supposed to be equal to negative 12. That goes to 0, so 6y is equal to negative 12. Therefore, y must equal negative 2. So as our ordered solution, if I wanted to write it in that manner, I could say that the ordered pair x comma y comma z must be equal to, the x was 5, the y is negative 2, and z is 0. Final solution.